So volumes, disk and washer first. Formula, if you don't know the formula, that's kind of it, game over. There's nothing you can do if you don't know the formula. So I remember that the volume for the first case was pi r squared minus pi r squared, integral from a to b or c to d, pi r squared minus pi r squared, and then dx or dy. So if it's a disk, you just don't have the whole. That means the second one is 0. The second radius is 0. That's why it's the same case, just a more general. That's it. So I remember one case. I don't like remembering too many formulas. So that's what my recommendation. Then we remember that if we're rotating about x-axis or anything parallel to x-axis, which is y equals 5, y equals 17. Visually imagine what is y equals 5. That is a horizontal line. It's parallel to x-axis. Then it's a dx case. Then I don't have to write down. It makes sense that whatever is about y-axis, that is dy case for the washer and shell. That is going here. For the washer and disk, that's what I'm trying to say. Then for the shell, it's the other way around. And also the formula is different. V is from A to B. Then what was the formula? 2 pi r, because it's circumference. If you remember, 2 pi r h. And then the same thing, dx or dy. But in this case, rotation happens about y-axis. About y-axis. Or anything parallel to y-axis if we do dx. So that is a big difference here. Big difference of which formula to use. Let me know if I make mistake. I don't teach in the evenings for a reason. So just let me know. Now, this is the example here. They don't tell me what to use. Step 1, draw the graph. Sketch the graph. You don't have to be precise or beautiful, amazing about this. You have graphic calculator or you have a basic knowledge of basic functions. That's what we assume you do. X cube looks like a chair. It's not like tangent. It looks like a tangent, but tangent is fixed between two walls. X cube is just infinitely growing like so, but it still looks like a chair though, like so. Then this is the idea here. Then we have a line. So maybe sine, if you're afraid to forget, that is x cubed. Then we have a line, y equals x. That's the easy thing to draw, y equals x. Then we have now two areas, but when they said x is positive or 0, that made us understand that this is the area they're talking about. This is the area between graphs. You can find it top minus the bottom or right minus left in this case. So we can see now that the most important is how to rotate it. Rotation happens about x-axis. This is a nice notation for this rotation. Look at that. So before you draw the 3D picture, choose the case first, because if it's shell, I do not recommend drawing the picture. You can still do it, but just be careful with limits of integration. Step 1, sketch the graph. Check mark. Step 2, choose the case. No, choose the method first and then the case. The method, if you want to do disk, washer, or shell, disk has to be filled in. So solid, filled in. Washer is hollow or empty. Washer can have something inside, empty. If there's a water, it can contain water, while disk is solid. Disk is called disk method because we're slicing with disks. They don't have any, like Ninja disk, they have no holes inside. While washer is called a washer because we're slicing with something that has a hole inside. That's why I like calling it ring method. Both of these have thickness dx or dy, so they're not flat. Both of them are 3D objects, and they are delta x, or delta y, depending on how it's standing horizontally or vertically. Horizontal slicing or vertical slicing will have different representation of dx or dy. So if the shadow of the thickness, which is called projection, goes to the x-axis like so, then it's a dx case. That's how sometimes people see it. That is for disk or washer. For shell, it's different. So we're rotating about x-axis. That means it will be dx for washer or dy for shell. And again, some cases can be done, most cases actually can be done both ways. And the answer should be the same. We had this example in one of the quizzes. So choose which one you want. Well, if you want to do dy case, then x have to be solved for y. And like, why would you do it if there's no specific reason for that? The reason would be if it's convenient. And that's why I figure out to choose the x case. I know it's washer, not a disk, because when the rotation happens, there will be an empty piece inside, like so. Now I draw the picture. So for washer method, I will do a 3D picture. For shell, I will not do 3D picture. Now we have a 3D case over here. We still maybe want to check if it's the x or the y case, just carefully. We know it's the x case because I just mentioned disk and washers are consistent. If we're rotating about x-axis or something like looks like x-axis, that's a dx case. But why? Because when I'm slicing all of this 3D shape with what did I call them? Rings or washers. I like to see them as rings. The thickness will be described as the x-axis value units. See, the shadow or projection of the thickness of this ring is on the dx, on the x-axis. So I'll call it delta x, which will becomes dx in the integral. That is how also I know. Same here, like so. So it is the x case. Maybe write down either because it's the rotation about x-axis or because it's a vertical slicing. Step 3. Write down the formula. Now you chose the case, you chose the method. So now it's time to write down the correct formula. V equals pi r squared minus pi r squared. Pi r squared minus pi r squared dx from A to B. Okay, that is already like half job done. If you did not, if you know what's going on here, it's already good. Nice. After this, we start actually figuring out what does this formula mean. The formula says that you first figure out the solid volume, then you figure out the whole, the volume of the whole. The solid minus the whole gives you, guess what, the difference. So it gives you the ring, right? So that makes sense. Step 4. V equals A and B are now depending on X and value. A and B are X values. That means width of this 3D object. The object starts obviously at 0, but I don't know where it ends. B, question mark. So we have to figure out what this B is. B will be found from points of intersection. Like this is where the object ends, the 3D object. I have to find B. So points of intersections, if needed. Sometimes they give. Sometimes they're obvious also. If there's a wall, you know the wall. Y equals x cubed and y equals x gives you a nice equation with two unknowns, two equations. So you have x cubed equals x. Always recommendation, move everything to one side. I move to left-hand side. Factor out, don't divide by x. That's actually not correct to do. You don't divide by x because you cannot divide by 0 and x can and is 0 in this case. Instead of factor, you factor out instead. So you'll have x factored out, x squared minus 1. And now you have 3 solutions. Can anyone explain why we have 3 solutions? Is it correct or not? X is 0 and x is plus or minus 1. Why do we have 3 solutions? I thought we only have 2 points, this one and this one. Do you know why I have 3? And why it's like minus 1? What is the idea behind that?
Because it would be the other value for the negative number.
Exactly. There's one more over here. Good job. There's one more on the left. And without this, know that x have to be positive, we would actually have 2 areas. They're symmetrical, so we could just multiply by 2. But that's why you should understand, good job, especially engineers and physics majors should really imagine what's going on. You'll be building things. So make sure you know what you're building. So we need 0 and +1. We don't need the other one. 5, we can start building the integral. V is from 0 to 1. Nice. Pi r squared minus pi r squared dx. Each r is the area between graphs. Since we're working with the x case, area between graphs gives you top minus the bottom area. Beat. So r, any r, is area between graphs, curves, area between curves. We had different definitions of this chapter. And it's either top minus the bottom for the x case, or right minus left for the y case. Let me just put it in the box. Either or. So it's always bigger minus smaller. That's how you should remember it. Bigger minus smaller. Whatever is on the top is bigger, and whatever is on the right is bigger. That's how you see. Since we're working, so maybe let me put it in. Normally, if you want to sketch a graph, I can show you. The first one is top and the bottom. Let me do another count. The top, the bigger one is in green, and the second one is the right is bigger in green. And then the one at the bottom, it will be wiggly, and the one on the left will be wiggly. So either I am scanning from top to bottom, from top to bottom, from top to bottom, or from right to left, right to left, right to left, like so. See, green is always bigger, blue is always smaller. So the logic actually is the same. Yellow, this is the area. Two cases, the x and dy. Like so. So that's the review of the topic area between graphs. And now we will be implementing this knowledge into the topic of volumes. So again, area between graphs will be extremely important in calculus 3, discrete math, differential equations. It's kind of like knowing product. What is 5 times 7 was the important, because then it exploded in lots of knowledge. Area between graphs is the same thing, just in 2D and 3D. So the first R, it's a big radius. Since we're working in the X case, it will be top minus the bottom, top minus the bottom. And that radius represents the filled in part of the solid part of the object. So I'm going back to my graph, and I'm putting the laser. I like explaining with the laser because it's kind of awesome idea, I think. And I created it, so I like it. So I put the center of the laser in the center of the object, which is the axis of rotation. It's called axis of rotation. So, and I'm shooting it up or down. Go to the function that we know. If we know the positive function, go up. If we want if we know the one below x-axis, then go down. Usually it's up. We shoot, doesn't matter actually, the answer will be the same if you correctly know the order. I'm shooting the laser up until the end of the object. This radius shows me the whole object, implying that it is solid. Capital R. Capital R is the distance between the outside part of the object and the center of rotation, ignoring any pieces inside. This R is the function at the top minus the function at the bottom. The function at the top is a line y equals x, and the function at the bottom is a line y equals 0. So that's what we're going to write down. What do you think about that? Does it make sense? So we're going to write down y equals x was at the top and y equals 0 was at the bottom. That's why I don't like teaching the disk, because as you can see, this was a disk actually. There's no hole, so it's a disk. But then you have to memorize different methods and stuff. I think covering top minus the bottom is easier, because then it's one case. Let's go to small r. The small r, I'm repeating the whole process, but now with different color, a different goal. Let me choose like all colors already used. Purple. Purple is good. I'm putting it in the center shooting at the same direction as before, but stopping at the wall inside. That is representation of the hollow piece, because you see, it's like literally in the hollow piece, right? So you can see it. It shows me how the hollow piece will look like. So this is a small radius that only shows how big is the empty piece. It also can be shown as top minus the bottom. But now the function at the top is y equals cube, and the function at the bottom is still the floor, y equals 0. R, small r, is x cube minus 0. So I have y equals cube, the chair function, the chair looking function, minus the floor, which was the axis of rotation. Still top minus the bottom, but now it's a small radius. So that's how you build formula. This is like the most important part. Do you agree with this? Do you have questions? Can you do it by yourself? And so on. Let me check the chat. Oh, wow. No questions. It's like, it's either amazing or it's really bad. Which one? Which one is that? Okay. Hope you can do it in the test, because like it's there. And now you finish the integration. Hopefully it's not too hard. What is this washer? So the first, yeah, the whole thing is a washer. Yes. The whole thing is a washer because it has an empty piece. So let me do it. Washer. It's a washer because the 3D object looks like this: line outside, cubic function inside, line outside, cubic function inside. And when you actually see there's a 3D object, there's an empty piece inside. So that's why it's a washer. Good. Finish integration. That's pretty simple. Nothing is interesting here. Integral from 0 to 1 pi x squared minus pi x to the 3 times 2 is 6. Not plus 2, which is 5, right? So it's 6. We multiply. Dx, integrating, plugging 1 and 0. 0 makes everything 0, so I don't care about that. 1 will be important. So pi x cubed over 3 minus pi x to the 7 over 7. Like that. That better be a positive number, because if it's not, we messed up. And in general, in your exam, that's how you know. If it's a positive number, if it's a negative number, just check the order. Maybe you messed up the order or calculation. So it's actually a good sign that there's a mistake there. Don't leave me a negative number for the problem about area, volume, arc length. Those are physical objects. They have to be positive. Units cube. What do you think about that? What do you think about that? Questions, ideas, suggestions? So I actually have the same problem, but shell method. Can we do shell method for this problem? Yes, we can. Let's do that. No questions, good. Part 2. What if I have the same example, but it's rotating about y-axis? That's some good example. I think I put something like this on the quiz to show you that some cases can be done in 2 ways. I could do shell method right away, but I want to rotate it about y-axis to just have another example. About y-axis, and also to show you example 2, how the picture would look like. So we recreate everything. It will be a cubic function, which is like a chair. Looks like it's kind of like this, very wide. Now y equals x. Oh, it's a different example. I just noticed. Okay, fine. We can do a different example. Well, like why? What was the difference? I changed the example. Let's not change the example. Let's have the same. So line was outside. Area in yellow. And this time we're rotating about y-axis. Here it is. So now there are two ways of seeing this example. Either I will do, let me do cases, or no, methods. I will even put it below. Methods to choose from. So either I will do dy case for washer, because we're rotating about y-axis, or I will do dx case for shell. And now it's up to you to choose which one you like more. The answer should be the same. So if we do washer, we'll have to solve everything for x, which is actually not too bad. It's going to be a cubic function of y. And so we can actually rewrite it like so. Integral will be pi r squared minus pi r squared dy from c to d. And we're going to rewrite everything as x equals cube of y and x equals y, like so. While for shell method, we can still do dx, and that's the beauty of it. Even though rotation happens about y-axis, we can do dx case. But then you have to remember a second formula, which you have to remember anyways, because I put shell method on the test already. So just letting you know, it's already there. So you need to learn it anyways. So the second formula is, we just reviewed it. It was integral, since it's the x case for shell, it's from a to b, 2 pi r h dx. R and h are functions, and they are in terms of x in this case. So let's write down both to compare. The first one will be, if we do a washer method, it will look like this, a line, a curve. So imagine the axis of rotation as a mirror. It helps a lot if you see a mirror. One circle, maybe some another circle. That's a cup. It's basically a ball, I would say. It's a ball because this ball can actually hold something like water or anything else, or apples. It's a washer method then. That's how I know it's a washer method. Now we're checking the height of this physical object. Because we're working with dy case for washer, integral will be, volume will be integral from c to d. That's the height of the object. Well, how high this function goes? It definitely starts at 0. It's standing on the floor. But what's the height of it? We have to find points of intersections again. When we solve it, we got 3 answers. Remember, we got them for x. X was 0. X is plus minus 1, but we don't need x. That's the thing. We need y's. But to find y's, you just plug it in. So because of that, let me write it down below the corresponding method. Because of that, we can find y. If I plug into any function, and luckily we have very simple functions. So those are roots, points of intersections. Y is 0, we already found that. And y is also 1, either from cubic function, 1 cube is 1, or just x equals 1. So I know it's from 0 to 1. Now it's going to be pi r squared minus pi r squared dy, and each will be right minus left. Right minus left, right minus left, r minus l. Each will be right minus left, bigger minus smaller, and each will be in terms of y. So it will be x equals and x equals, x equals and x equals, like so. Let's see how it looks like. Put the laser in the center and shoot it to the very edge to find the capital R. The capital R will be whatever is a function very, very on the right minus the function on the very, very left, which is the axis of rotation in this case. The function on the very, very right is not y equals x cubed anymore. It's x equals cube root of y, because we need to write it down as x equals blah, blah, blah. Whatever is a function on the left is not y-axis. We're going to call it x equals to 0. So it's going to be whatever is on the right is bigger, square root of y, cube root of y, minus 0. Think about this a little bit and let me know, what do you think? How does we know if it's shell or washer? In this case, I'm choosing. And in general, as a scientist, you're supposed to choose. Sometimes it's impossible to do one method than another. I will show you, we had example on exam, remember last time? When it was impossible to do one of the methods. Because in this case, so the question in chat, how do we know which one to use? In this case, I was able to solve for x, but what if I'm not able to solve for x? Then one method is already not working right away. The way to choose is convenience. And which one is more convenient? Rotation was happening about y-axis, so it's going to be dy case for washer. Are you okay working with dy case? If yes, then choose that. Or it's the dx case for shell, but then the formula is different. Are you okay with that? Then do that. So we did not finish. Small radius. A small radius, zoom in, put the laser in the center, shoot till the middle, to the inner wall. So we have two walls, outer wall, outside wall, and inside wall. Then that's going to be small r. Right minus left, again. The function on the right is a line, not y equals x. It's x equals y. So remember, everything has to be consistent. If everything is in terms of y, everything inside better be y. So x equals y minus y-axis, which is 0. That is the correct integral for the dy case of the washer method. Washer dy case, rotation about y-axis or anything that looks like y-axis. And we can finish integrating it. It's exactly the same we did before, power or blah, blah, blah. So I don't want to do that. Shall I move to shell? So you always do total minus the inner. Yes, exactly. Total minus the inner. Yes. That is the correct comment. Filled in. So I actually can write it down. I would do filled in or total. Fine. Total is good. Total minus empty. Yeah, like so. Total minus empty. Now about shell method. Shell method have a different formula. Here it is, 2 pi r. So integral will be from a to b. I can kick out 2 pi right away. The beautiful part of this, that this is not going to be changing, so it's fine. R is your variable x or y if there's no shift. Since there's no shift, rotation happens about axis, not some kind of y equals 7 or y equals or x equals 17. R will be x or y if there's no shift. So radius is x. And I can show you right now in a second why. While h is a function, and this function will be top minus the bottom. Top minus the bottom. How do I know? Because it's the x case and because it's the area. Height is the area. And we also don't know a and b. So let's check. A and b is the width of the object. So it's going to be from -1 to 1. What do you think? For shell method. So many students write down it's from -1 to 1, which is not correct. That's why for shell method, I usually recommend not to draw the 3D picture. Because shell methods use unfolding strategy, we unfold like a paper mache, or like an onion. Onion have shells. To know the volume of the onion, we unfold each, and when we unfold it, it becomes a rectangle. And the rectangle have height, and the rectangle has a radius. Because when folding it versus slicing it, if you don't have a 3D picture, you will not make the mistake that we don't need this 3D object A and B. We need only 2D picture for that. So for 2D picture, A and B is still 0 and 1. 0 and 1. It's not from -1 to 1. Yx is the radius. Let's see. For shell method, which I will redraw here so we can see it better. For shell methods, we're only looking at 2D picture. which is a cubic function. Oh, that's ugly. It was beautiful until the end. Like so. We have a line. This is the area we're talking about. And then the radius is, so we're rotating about y-axis, right? So what I was trying to say. Oh, the top of the height and the radius. How big, how wide this cup is in 3D. You can try to keep in mind that this is a cup in 3D, but this is the idea. So the radius, the biggest radius is over here, right? This is the biggest radius, whatever that number is. Now we know it's 1, but whatever. Half of the radius will be here, or maybe it's like smaller is here, tiny radius is here. Those are the radii of different shells, of different rectangles. So this is going to be the first unfolding. This is going to be the second unfolding. This is going to be the third unfolding. And each unfolding, like in the onion, will have smaller and smaller and smaller radii. Radii is a half, right? So like so. They all are halves, radii. Radius for each will be half of that thing. That's one of the reasons why we don't need the whole picture. We just need half of the picture. That's why we don't draw the 3D picture. And one more thing I'm trying to explain is why r matched with x. So again, how big is the radius for this unfolding, for example? Well, whatever that x is, that is the radius. If that x is 0.7, then the radius is 0.7 for that specific unfolding. How big is this unfolding? Well, whatever this x is, let's say 0.9, then that's going to be the radius. So in general, x matched with r. If there's no shift, that's exactly the same value, basically. That's kind of hard to explain. So it clicked to me at some point, and I don't know if it clicked to you or not. No shift, just put x or y instead of r. With a shift, I'll mention later. Now about the height. But the height is not just a variable. The height is area between graphs, literally. Check it out. How high? Should I delete all this? Yes, let me delete. How high is this object every time? All of these infinitesimal unfoldings. So infinitely many of those unfoldings. How high they are. Let's see. Let me choose another color, like pink. This is the height, right? This is the height. This is the height. This is the height. That's top minus the bottom. That's area between graphs. And that is my age. So top minus the bottom tells me that line goes first in this case. Y equals x. Then the cubic function, x cube. That is the shell method for this example. 2 pi r, which is 2 pi x, x minus x cube. And now you decide which one is easier to integrate. And maybe go from there also which method you like more. See, both are pretty easy to integrate. Both of them will be power rules. The second one is 2 pi x squared minus 2 pi x to the 4. And then you integrate that from 0 to 1. Super simple, super fast. Two methods are covered. What do you think? What do you think about that? Any suggestions, ideas, questions, critics? Maybe you understood it better and you can explain how did you understand it. That's actually nice to know. Some people have very good explanations. Sometimes I adopt some students' explanations because they're really good. Let's see the chat. 2 pi is main difference. And the multiplication by x. Yeah, two different formulas. So what if there is a shift? Oh no, what is a shift? That is just going to be so upsetting if it has a shift on the test. Yeah, so let's review that. Because we have, it's just input. Let's do the shift problem from the exam review. Which was, let's see if I have it here. Fine. If you go to the chapter, to our review, let me just go. I would just practice all of this. That's just the best part. So the X case is top minus the bottom. Exactly. Right minus left comes from dy case. So if you go to modules or just a website, and you will find there the review. You find a lot of things actually. So I'm gonna go to this one, the official page. Here, you just, if you can do all of this, you're fine. Because that's how I create tests, to be honest. It's just too much hassle to create something new. I like to choose from these questions, and we're allowed to do it, so why not? So area between graphs, top minus bottom, right minus left. But volumes already have this topic. That's why I don't see it as something different. And when I talk about shift, do you know what I'm talking about? I'm talking about this, not about x-axis, not about y-axis, but about a line. That makes it more complicated. So let's review that. About a line. Stop doing that. And there's more. See, the last problems for washers have the line, and for shells, last problems have last two problems, last three problems. So review these. For example, sine and cosine, blah, blah, blah. Let's see, which one do I want to review? Kind of all of them are pretty good to look at. Yeah, let's do the trig, for example. People don't like trigs, so let's do the trig function. So this one, the cosine thingy. Copy, paste. So we're still on the topic of volumes, unfortunately. Like been a while of talking, and we're still on the topic of volumes. That's why I wanted to start with it, because that actually requires some thinking, lots of thinking. I like use substitution integration by parts, which is pretty technical. This one requires thinking and steps. So what what integral represents the volume of the solid obtained by rotating the region bounded by blah, blah, blah. Okay, so we expect you to know how basic functions look like. I have video on that if you want in the table. Cubic function, quadratic function, cosine and sine. We think you know how it looks like. So we have like high expectations of our students. You guys know it. So just like, yeah, you know it. Cosine starts at 1, goes to 0, and then waves around like so. It is 1 at 0 and 0 at pi. Good enough, kind of like, because it's either this area or some of it. So kind of good enough. Let's see what they say. It says y equals cosine, y equals 1. Y equals 1 is a line. But what kind of line? Well, if this is 0 and this is 1, how do I know it's 1? Because cosine stuck in a tunnel from -1 to 1. Cosine and sine are both stuck from -1 to 1. So this is the line 1, y equals 1. Okay, good. And x equals pi over 2. Okay, so pi over 2 is halfway through over here. Like so. X equals pi over 2. So to connect all three graphs, it's actually not this one. I just realized it right now. It is that tiny triangle looking area over here. It's kind of lame. So tiny, but okay. And it's rotating, but y equals 1. Oh. Really? Okay, that's kind of also down, because then there's no shift actually going on. But okay, fine, whatever. It's rotating about this thing. Fine. So it is still a shift, but just without a gap. It's going to be disk method actually. So check it out. Do you agree? This is what this is what's going on. So I'm rotating the notation for rotation. The notation for rotation is this: y equals 1. This is not international notation actually, but I really like it. So this is like a little horn, right? Musical instrument, for example. So you can choose the method. Well, they say to use this conversion. And I don't want to solve for x. Like if I have to, okay, let's be consistent here. Solution. Just let me tell you my point of view on this and then see if you get it. So since it's rotating about y equals 1 parallel to x axis. So it's the x case for disk washer, right? And it's going to be dy case for shell. But if I want to use dy case, I will have to solve for x, and x will be arc cosine. And like, who wants to deal with arc cosine? And that's when you know, like, you don't want to do that. So that's like very obvious choice here, even though they told you, but like still, it just makes sense not to use shell method. So it's a washer or disk method, and it's the x case because we're rotating about horizontal line, and horizontal line is parallel to x axis. X axis is in black over here, like so. Now, then step 1, have the graph. Step 2, choose the case. Well, we definitely know it's not shell, but now is it washer or disk? I don't see any hollow piece inside. Do you see that this object doesn't have any space inside? That's why I know it's a disk method. Also, one more way to see it, when I start slicing it, this circle will not have any gaps. Where's the gap? There's no gap. See? So it's a disk. It's not a washer. It's a ninja disk. So now it's going to be a disk method. And step 3, no, it's going to be the x case. Okay, what is the formula for disk method? I just don't remember the extra formula. That's why I don't like doing it. I like seeing it as washer all the time. Just washer with no empty part. It's going to be formula, same formula, but with a 0 at the end. Let's see what I mean by this. A to b pi r squared minus pi r squared dx is just this r is 0. So why not memorize one formula instead of 2 formulas? And that's why I don't like how they're teaching it in this book. Too many formulas to memorize. I'm not good at memorizing things, so I don't like when they force people to memorize things. If I just remember one formula, that's good. Pi r squared minus pi r squared, but there's no inner empty part. No empty part, right? So no hollow part. That's why the second r is 0. So it's just pi r squared from a to b, and we can start building it. Where is my object from a to b? See, not height. We need to know it's from a to b. In this case, it's very obvious. It's from 0 and pi over 2, because that's where 2 walls breaking it. So it's going to be integral from 0 to pi over 2. Then I do pi r squared dx, and that's going to be top minus the bottom. How do I know? Because it's the x case. The x case tells me it's top minus the bottom. The y case tells me it's right minus left. So I'm going to look here, and I can repeat the whole process. Nothing is different for this method. Everything is the same. Let me choose beautiful green color. Put the laser in the middle. Let me put it. Yeah, it's fine. Shoot it up or down in any function I know. I like the one that's shaded yellow. That's the one I know. So in this case, I will shoot down. Check this out. This is what we need. This is my R, capital R. And we don't have small r, so we only need capital R. From the center to the very edge. It's top minus the bottom. Then what function is at the top? Y equals 1 is at the top, so R will be 1 minus, and what function is at the bottom? The trig function. In this case, it's cosine x. Let me write down and ask you if you're getting this. X equals, no, y equals 1 minus y equals cosine x, top minus the bottom, and all of this is squared. What do you think about this? Can you build this integral? Do you think it's hard? Do you think it's impossible? Do you think it's easy peasy? Do you think it's doable, but you need to practice? Which one? I hope nobody thinks like, what, did we cover this? That will be like upsetting, but you still have time to actually learn it. Even if you don't remember any of this, you got sick, for example, and you missed it, you can still have time by Tuesday. Top minus the bottom. You see the shift happened? This is the shift. But it's not really looking like a shift, something special. It's still top minus to bottom. In the book, they teach it as a shift, but it's actually not. It's still top minus to bottom. It's just before it was 0. What do you think? Okay, that was very quiet. So I assume either it's very, very hard or it's very, very easy. But we're done with the wash and shell method. Yeah. Should I stop the recording and do several topics or continue it as a one video? What do you think? Can someone type in and let me know what do you think is better? While I'm copying, pasting the new chapter. Should I do it like a single thing? One video is better? This was just washer and disconnect. Yes. Okay, I'll continue then. So no need to break, because before I did breaks in the classroom, and I have now I have videos for negation by part, especially, and U substitution separately too. Volumes we covered. Your job is to practice all of this. Just if you can solve these, you are set to go. Like I did not create anything super fancy. I just took some of these problems, one problem each chapter, which is perfect. Arc lengths. The problem is arc lengths, you need to remember the formulas. So if you remember the formulas, nothing super crazy here. Arc lengths at the very beginning. So we have 3 formulas, which I mentioned in class before. From A to B or C and D, huge square root, and 1 minus or plus. Derivative. Okay, let's not write down this way. I don't like it. Where is it drawn? Derivative, which is y equals f prime squared, and it's either dx or dy. See? So if you know that, you're fine to go. There's nothing seriously to that practice here. You just find derivative, square it, put it in the formula, integrate. That's it. If we don't ask you to integrate, then don't integrate. And that's very nice. This topic is done. Arc lengths in the Cartesian is done. And actually, same thing for all other arc lengths. They're all the same. Now, what I wanted to do is work while you're still here and feeling fresh. Let's do some work. And I like this example more. I would just take something that looks like an exam in the previous exam, which was, there was a dice in modules. If you go here, where is it? Jay Barraza made a very nice file and shared with us. And I kind of like it. Physics chapters are not my favorites. So he did very good explanation of different cases about the pool problems. Here it is. So Jay Barraza, he also teaches this class. You can see it. Some students, maybe some of your friends take this class. He did this, and I really liked it because he like really explained everything well. I think, I don't know, you can disagree. You might disagree. So let me take a screenshot and show you what is going on here. And to be honest, if you can do all the review problems on this topic, you're also fine. Nothing crazy. And I don't like those crazy shapes. They're good for homework, but they're not good for the exam. Crazy shapes like similar triangles and stuff. So this, for a test, it's nice to have something classical, either cylinder or sphere. Those are classical shapes which don't require too much work. So you just need to know how to build it. Okay, I had to practice a lot to memorize the formula, and then I did. So I'm very proud about it. I remember there's rho, and I remember it's G. So gravitational forces and rho density, and density can be different. If it's not water, it's chocolate or honey, it will all have different. And this is weight somehow. So sometimes they tell you, oh, the water is 25 kilos per cubic feet. Kilos per feet, yeah. Heavy, then you don't need to actually do rho and G, it's already given. Then there's the integral. And now from A to B, and then the interesting part starts. What was that? Area of Y and D of y dy. And now let me know if this is not correct. So just, yeah, just stop me or say something. So this is how I remembered it. And you might not have to like it. Maybe you have your own better way to memorizing it, especially if it's your thing. If like your physics major, then hey, good job. Just do your own way. Maybe you could explain better too. Rho is the density we gave it to you in this case. Again, like I did not read this problem yet. I'm just trying to find the information I need. So I can see this is density. See, it's water is density. I saw it. This is like this big number, kg/m cube. Kilogram per m cube. It's funny, but in my language you say it kg sometimes. Kg. Anyway, it's 1000. Put it here. Nice. Then G, I like, okay, I think it's 9.8. Here it is. It is 9.8. I was correct. Very satisfying. 9.8. Then the hard part starts. So A and B are the water level, the level of the water that you want to lift. So let's not call it A and B also. Since we are with dy, let's call it C and D. Again, books call it whatever they want to call it. There's no consistency in this chapter between books. So don't be upset if you see that. C and D is the water level before you start moving it. And only the one you want to actually lift. You want to lift. So if they say half of the water, then it will be different. In this case, now I have to read the whole problem, which is kind of annoying, but okay. So a cylindrical tank, we're gonna need this later for A. Standing on cylindrical base, same thing. Radius later, height later. What we need to know is how much water is there. It says it's full of water. Oh, okay, so full. Oh, it's not, check it out. It's actually at the mark 4. So, okay, fine. I did not expect that. I thought it was full. So it's full to the mark 4. And don't say it's full. Can you just say it's level 4? It kind of misleading, but okay, fine. English is fine. So this is gonna be my level. This is, no, actually I don't know. They need to tell me how much to lift. Find the work required to pump all the water. Okay, so they want me to pump from 0 to 4 meter high level of water. Then it's from 0 to 4. That's how I know. Like before we start pumping, that's the one. That's the number. That's what I need. I can show you that it's not the only answer if you're hesitating about this. Yes, there's several ways of doing it. And my browser just like not liking this. Oh, so there are several ways of seeing it. And the way I like is this one from 0 to 4. As you can see, either from 2 to 6 or 0 to 4. Just learn one way. I like from 0 to 4. That's the one I understand better, and which is consistent to this. So it's nice to be intelligent and smart in general, but for the test purposes, I'm being consistent, 0 and 4. Then A and D happen. A actually is not too hard unless the shape is hard. A is the area. So what is the shape of this 3D object? Well, now the graph is important. Okay, fine. Let's draw how the tank looks like. It says a cylindrical tank. I know how the cylinder looks like. If you did not know, you better do, because that's going to be everywhere. Cylinders have lots of properties, so in mass, they show up everywhere. Here's a cylinder. Then it says it's a circular base, because you know, maybe it's not. Okay, now I know that it has, and the radius is 2. So R is 2. And since it has a circular base, I know the area. The area is pi r squared, which is pi 2 squared. Pi 2 squared. That's the area. Times. So what we're doing here is we are lifting all of these slices of, those are horizontal slices of water. That's why this topic comes after the volumes. We're lifting those infinitesimal slices of water, so it's infinitely many of them, up. But to lift them, we need to know 2 things, 3 things. 2 things are about the shape of each slice. The shape of each slice is this disk. This disk has area pi r squared for the specific case, and the width delta y. That's what is happening here. And we're lifting them all. So because radius is fixed here, you see, if it's a cone, radius will be always different. Then we'll have to find some relationship for radius. In this case, radius is always 2. So it's going to be pi 2 squared. That is my area of each lifted piece of water. Finally, the last piece is how far we are lifting this. Y minus what? That is a shift over here. The shift is going on. So that is, let me see, I have very good notes here somewhere. The shift is distance to lift. So like how far do we want it to lift all of this? Y minus what? Y is 80 moments at which the water is located right now. So this slice of water is over here, right? That's some kind of height y. This slice of water is over here, some kind of y. This water is always at the top. This water is is at the bottom. So that's why it's y. And then y minus what? How much it's each slice have to travel. So distance to travel or distance to lift. Let me write down that. When A was pretty simple to understand, not simple to find though, it's area of cross section of each slice. So cross section or slice, right? Then D is a distance to lift, distance to lift. Well, they told us that we are lifting. Let's see, where do we start? So no, it's actually not important where do we, well, if it's half of the water, we know then where to start. But in this case, it says it's 6 meters high and we want on top of the tank. No fountain is. So this is the height then. So it's y minus 6. That's it. That's what I wanted to explain. So we only have like 3 numbers to choose from here. Where does the 4 go? 4 is a watermark. So from 0 to 4. 2, that's the radius. That's going to be part of the area. Finally, D tells you how far the water will go. And it says 6 meters far. If there's a fountain, then it will not be 6 meters. But in this case, there's no fountain. And again, just to mention, it's nice how he explained here really well that you can see differently. You can see that we're only lifting y, but then from 2 to 6. Y from 2 because 6 minus 4 is 2, blah, blah, blah. But I like this way. Is it 6 minus y or y minus 6? Which one is correct?
I was going to say, I think it's 6 minus y.
Yeah, it's 6 minus y. The moment I saw it, I actually realized that's 2. Let's check. Actually, very interesting that when you make mistakes like this, physics is supposed to tell you if it's correct or not. Remember, the answer has to be positive. So it's if at any moment this equation, this formula, it's not equation, this formula, this volume gives you a negative number, then you messed up. Let's see, if I plug 4 over here, 4 minus 6 is negative, then I know it's messed up. See? So that's actually, as a mathematician, I know that something is off. This answer will be negative. When I get a negative answer, I know it's wrong. What can be fixed here? It's not from 4 to 0, so it's only the other one. Either some constants are wrong or the order of the shift. This is the shift I'm talking about. So fix it. It should be 6 minus 1. 6 minus 1. Let's check again. If I plug 0, 6 minus 0 is positive. So that's the lowest level for y. Again, remember, this is y equals 0. Then y will be 1, then y will be 2, y will be 2.7, blah, blah, blah. Then y reaches its maximum. Y is 4. 6 minus 4 is positive. So that is the idea here. Does that make sense? What do you think? Let's see the chat. What are the units for work? What do you think? Who wants to answer that? Work. Jules, Jules, I always say it's wrong. Julia, Jules, okay, yes, I remember it's J. I don't require this knowledge in my classes. People who take physics, they will be bothered by units every day, so I don't care, to be honest. So that is all you need to know about this chapter. Just practice these examples, you'll be fine. What do you think about that? Can we move on? Let's move on. Let's move on to something not very intellectually challenging. Improper integrals and also table integrals. So back to some kind of, trig functions. We can still move. We can have more examples for trig functions, but we already covered actually pretty well in class. Check the videos. I have like 2 examples, I think. Between curves. Let's go to table integrals. I'm afraid you don't remember even that topic at all. Table integrals, they look like this. There are hundreds and hundreds of table integrals. Where was I? It was here. This file. So we did integration by substitution in class and checked my videos, previous videos. Integration by parts, we did that. That's it. You have to keep practicing. Trigonometric functions using tricks or with tricks. We practice these. Partial fractions coming right after this. So let's do tables. Check this out. Check those tables. Let me just show you right here. Oh, but in the notes we won't be good. Fine, let me take a screenshot. Any kind of problem, just copy. And paste. There are hundreds and hundreds of table integrals. We give you the integral, we give you a table integral and say, use this here. And your job is to be able to use. So it's basically a tool. It sounds like a boring, useless topic, but actually it's a tool. In STEM major, you will have so many different cases. Your job is to be educated enough to know of existence of those tables and to know how to actually use them. So this is the formula they want us to use. And they want us to use it to find integral of x over 1 over e to the minus x squared. Well, let's see. We have 1 over 1 plus, we have 1 over 1 plus e to the u. We have x over 1 to plus e to the minus x squared. Well, the whole hint here is like this part. This is literally the hint. E to the u, e to the minus x squared. So maybe, and it's just a guess, I'm not claiming that's correct. Maybe if you set u to be minus x squared, it will work out. Let's check. If u is minus x squared, then du will be minus 2x dx. Interesting. We have, let me change the color, dx times x. And we can find it now over here. We can find it. The goal is to make our integral look as much as possible as this integral scale. Scaled means times some kind of constant. But if it looks like that integral times some kind of constant, we know the answer right away times that constant. That is the goal. So we solve for x dx. That will be minus 1/2 du dx. And we're plugging the first equation and the third equation into the original integral we have. U will be plugged into exponential function and then x dx into this blue part, x dx. Integral x over 1 plus e to the minus x squared dx is integral. Let's do the simple part first. 1 plus e to the u. That's what's the whole point here, like 1 to the e to the u. Now it looks very nice. 1 plus e to the u. And then x dx over here becomes minus 1/2 du. Well, that's what we need. Let's kick out minus 1/2. That will be 1 over 1 plus e to the u du. And it's exactly what we have on the left-hand side of this beautiful, amazing formula. Here it is. 1 over integral of 1 over 1 plus e to the u du. So now we know the part in yellow. The part in yellow will be multiplied by -1/2 in front, open the brackets, and write down the right-hand side. Right-hand side of the formula. U minus ln 1 plus e to the u plus c. Someone already solved this integral for you. So you just like to use the result. Close the brackets. Now, nobody knows what u is except u, so you have to change your u back to the minus x squared. Minus 1/2, u is minus x squared minus ln 1 plus u to the minus x squared plus c. And everything is multiplied by -1/2. Either you simplify or not. This is the answer. How about that? How about that? What do you think about that? Can you do that? Partial fractions we're going to do right after this. What do you think about that? Is it easy, hard, or horrible, or a little bit of everything? So just easy. Sounds as easy. Yeah, I guess like just don't freak out. Try. It's kind of a game of matching. It's more like to match stuff. So move on. That's kind of all we need. Let's do partial fraction decomposition because it's pretty important topic. It doesn't seem to be important from the first glance, but actually this topic taught everywhere. And it has lots of applications. So partial fraction decomposition. Your job is to remember how to create them. Well, actually how to solve them as well. I just realized I should not say that. Step 1, you know how to create them. Step 2, know how to solve them. Check the previous exams and quizzes. I did give you lots of practice on that, and your homework will give lots of practice as well. And the review, as you can see, there's lots of practice as well. Go. So first, let's practice creating fractions. And then we're going to practice solving one of those. Come on, tablet. Doesn't like working more than 1 hour. That's the problem. Maybe I should close everything. Whatever. So the classic case is you have factors in the denominator. And I'm not going to force you to actually create those factors. Too much time wasted. So I already factored it for you. Now you have factored form in the denominator, luckily. And now you just need to create fractions. If it's just like this and there's no powers, it's going to be integral. Don't forget it's still integral. A over x plus 6 plus b over x minus 2 dx. Now that is because those are linear and they're not repeated. Linear and they're not repeated. So you have a and b, one for each. Then you solve, and I will show you in a second how to solve. However, if you have example like so, then let's practice. Again, integral dx it's still integral. The whole idea is to break complicated integral into easier integrals and then integrate the easier integrals. Why are they easy? Because these integrals are just logarithmic functions. For example, for the specific one, it will be a ln x plus 6 divided by 1. Don't forget to divide by the leading coefficient because actually there's a chain rule happening over here. So divided by 1 and plus b natural logarithm absolute value x minus 2 divided by 1 plus c, of course. It just doesn't fit and I don't want to write it down like so. I guess it should. Plus c. And then we want to find WTF a and b. So integration actually here is easy. It's an easy part. But finding a and b is not hard, but just time consuming. But you can also use graphing calculator to do it. They do it for you if you learn how. How about the case I circled? That case has 4, x minus 4, and it's the same thing as before, linear, not repeated. So it's going to be a over x minus 4 plus. But then the other guy is linear repeated. Repeated means it's linear, but it's squared or cubed or fifth power and so on. So it's linear, it repeats. Because it repeats, it will have b and c, x minus 3, and then c, x minus 3 squared. And then it will keep accumulating until all the powers we need. So if it's to the fifth power, you will have b, c, d, e, f, and so on. But it's still linear. Because it's linear, at the top we have constants, a, b, and c. Finally, one more example is this one. I want to show you 2 more interesting cases. If you have integral, and I don't care what's on the top, and now it's x squared plus 3 multiplied by x cube. Let's do x cube. Yeah. And multiplied by x to the squared minus 1 squared. Now what? That's going to be the huge one. So let's see what's happening. The first one is not linear, it's quadratic. Quadratic. Quadratic has a shape of ax plus b, like so. And it's not repeated. Repeated means there's no power like the other one at the end. So it will be integral ax plus b over x squared plus 3. That's the end of the first piece. Do you agree? So it's always 1 power less at the top. If there's a square at the bottom, it will be x at the top. If there's an x at the bottom, it will be no x at the top, because no x means x to the 0. Now, x cubed is linear repeated. We don't treat it as cubic function. We treat it as x times, we treat it as x plus 0 cubed, and it's linear repeated 3 times. So it's going to be c over x plus cube. That is interesting. To be honest, you can treat it differently, but the answer will be the same. But this is the easy way to remember. X cubed, c over x, d over x cubed, and f over d over x squared, and f over x cubed. It's a linear but repeated 3 times. Finally, the last one is the hardest one. It's quadratic repeated. Quadratic repeated. So it will be ax plus b and 1 more ax plus b. But now you have to change letters and stuff. To be honest, if you're kind of done with creating new letters, you can just start repeating them with 1 and 2 and 3. So it's going to be, for example, let me put it in red color. It will be x squared minus 1. Actually, x squared minus 1 should be broken into pieces. Let's put plus. That's the one template in real numbers at least. X squared plus 1. I change it to plus. X squared plus 1 will have ax plus b, but because I already used a and b, I will make them a1 and b1. That's a clever way to like start thinking about the alphabet. Ax plus b once and ax plus b2. So those are the cases I just gave you. And of course, there's the x at the end. So here are the cases. What do you think about that? 11 and 3, says Charlie. What are you talking about? How many questions there are? No, it's 14 and 3. Question, at least this semester, final exam has 14 questions, multiple choice, and 3 free response. So this is the one when we just want you to actually find the formula. But how about the one we actually want you to solve it? Do you remember how to solve this? Let me quickly solve it for you and we can move on. So integral one, let me do a new example just to like practice something. Why we have x plus b for x squared plus 3. So this is quadratic function. So whatever is quadratic will have ax plus b on top of it. Yeah, so we do right now the example, we're going to find a, b, and c. But my point is to explain, quadratic has ax plus b on the top. A linear will have a or b on the top. That's the idea. So that's kind of two cases of scenarios. Example, let me create example on the flow. So like 5x and then 2x plus 3, probably will be horrible numbers, but whatever. Let's do that. We don't know how to integrate that. No integration by parts, use substitution. You don't want to plug a sign in, don't you? So like what else can work? This is very obvious partial fraction decomposition case because you see fractions, okay, see polynomials. In Wikipedia, if you check the code, polynomial p of x over q have to be less than degree of q. If not, you perform long division, all that kind of stuff. You can check Wikipedia on this. So the whole power of the top is 1 because it's x to the 1, and the whole power at the bottom is x squared because x times x. That falls into the theorem, and the theorem says it will be a over 2x plus 3 plus b over 7, or you can even see it as 2 integrals like so. Both are fine. Those are easy integrals to integrate. Again, don't forget to integrate that at the very end or else. Some people forgot, and that's lots of points if you don't forget. If it's a very small question, remember people messed up, they're not finished to integrate. If it's multiple choice, it's kind of obvious that the number doesn't look like an integral anymore. 5x is completely ditched for now. A good question, what is happening with 5x? It's not used until the next step. So step 1, break the fraction into partial fractions. When we're breaking fraction to partial fractions, we don't care about the numerator. We only care about the denominator and the shape of it. Shape of my heart. That's the thing. Step 2, now you care about the numerator. So let me quickly finish this problem. It's going to be times, let's multiply by the denominator, 2x plus 3, 7x minus 1, multiply minus 1, 2x plus 3, 7x minus 1. Okay, there, multiply all of it. Now I know that this completely simplifies to 5x equals, that's where numerator matters. This guy only cancels out 2x plus 3. So now I have 7x minus 1 times a. This guy cancels out 7x minus 1. So it's going to be 2x plus 3 times b. So some people mix those up. Which one multiplies by a, which one by b? It's always the opposite one. So it's always not the one that was on top of each other. It's always the other one. Now you need to solve for a and b. And there's two methods. Method 1, collect the terms. And I don't want to do it now because it's easy in this case to plug some random numbers. We multiply both sides of the equation by the denominator, exactly, by the biggest denominator to get rid of the fractions. So plug easy numbers or inputs or values is a convenient way for most cases, unless they're too hard. So check this out. For easy questions, it's actually easy to plug things in. For example, why like to plug 0? So like if x is 0, I will have left-hand side 0, right-hand side 0 minus 1 multiplied by a, and then 0 plus 3 multiplied by b. This is really amazing. Very nice equation. Now, let's plug some kind of other number. You can plug some of the roots here, or you can plug any random number, actually. You can plug 1 or minus 1. Who cares? You can plug the fraction if you want. So either you can plug 1/7. Why not? Then it will be the root. Or you can plug 1. Also will be nice. So let's plug 1, for example. Why not? Whatever you want, actually. You just need 2 equations for 2 unknowns. That's it. If I plug 1, it will be 5. 7 minus 1 is 6a plus 5ab. And you solve the system. If you plug one of the roots, just one of the variables disappear. Maybe that is easier for you. So if you don't like that, plug one of the roots. So if you don't like that, maybe plug 1/7. See what's going to happen. If I plug 1/7, it will be 5/7 equals 0 times a. So a disappears. But then you will be 2/7 plus 3 multiplied by b. And you solve for b right away. B will be 5/7 divided by symmetry 21 plus 2 is 23. So 23/7. I'm flipping the fraction. Gives you b. Yes, I think I'm correct. So it's 5/23. B is 5/23. Plug this in any other equation, even the one with x equals 1, whatever. A becomes A is 3 times B from the first equation. So it's going to be 3 times 5, 15 over 23. Boom, you found it. That is not the answer. If you give me this is the answer, that is bad. That means you don't understand what was the goal. The goal was to integrate. Integral 5x over 1 becomes 2 small tiny integrals. The first integral is A over 2x plus 3, and A is 15 over 23 divided by 2x plus 3 plus B over 7x minus 1. And B is 5 over 23 divided by 7x. I said black, please. Give me black color. Thank you. 7x minus 1 dx. It gives you 2 integrals. See? Integrate that. Constants, just kick them out. Don't care about that. Oh, 15 and 20. Oh, okay, it's fine. ln 2x plus 3 plus 5 over 23. Find the mistake in this answer. That is the answer. Don't forget absolute value, please. That is important. And I made a mistake this time on purpose. What is the mistake? Chain rule. Exactly. We undoing chain rule. To undo chain rule, I need to use U substitution. So U substitution for each integral. Let me write down as 2 integrals. It's 2 integrals. See? So you actually have to perform U substitution. And U substitution has a shortcut for logarithmic function if you want to learn it. U substitution says when you differentiate, you will multiply by 2. But when you integrate, you divide by 2. You divide by the leading coefficient. Divide by 2 and divide by 7. Don't forget that. And don't forget absolute value too. Good. What do you think about that? Good job, people who noticed. Look at that. Good job. That's all you need to know for the partial fraction decomposition. My coffee got cold. Life is sad. The coffee is cold. Let's move on to Taylor series. And then polar and other things you will review by yourself because we just did it actually. It's nothing there to review. Areas are hard in your homework, but on the test I just put very classical ones. Okay, so we did this numerical approximation. Check the videos. You need to remember the formulas. Honestly, that's it. I don't want to do that too tedious. It will take half an hour of the video. That's why I have videos on that. But you need to remember only 2 rules, trapezoid and Simpson's rule. So good enough. Practice number 28 and number 29. Those are good, very classical examples for the test. Well, they're only 3 examples actually. So again, I'm telling you one more time, I took examples from this review. So if there's only 3 examples, that's one of those 3 are problematic. Improper integrals. Do we need to review improper integrals? Like, let me see, what is in the exam review? Oh, improper integrals. Like these guys. Let me just annotate. Let me have good notes. I keep forgetting that I'm having good notes. I will give you this PDF file. So, where's my integral? These guys. Improper integrals. After this, let's do Taylor series because I think that's where people just get lost. And yeah, it's not going to handle more than a couple hours. My tablet's dying. So sad. Improper integrals, you use limits. And then you need to know how functions behave at infinities. So, at infinities, minus infinities, and zeros, for example. So for 34, it goes from 2 to infinity, e to the minus 2x is improper integral because I see infinity, and because it's not definite, it's not defined. So to define this integral, we need to use limits. Limit, write this integral with as a definite integral from 2 to some kind of fixed number b. And then don't forget that b actually have to be set to go to infinity, like so. Then you have a function inside e to the minus 2x dx. And then you use a limit. So you will have limit b goes to infinity. Again, this is where you practice use substitution. Copy exponential function, divide by the leading coefficient. But it's definite integral from 2 to b. So I'm going to plug the top minus the bottom. E to the minus 2b, e to the 0 is not 0 for you to know. Many students always think that e to the 0 is 0, which is not true. Now, the second part is some kind of constant. It will not change the result if everything is infinity. So we only need to calculate that if it's not infinity. So let's see if it's infinity or not. This is what matters. What is happening with e to the minus 2b when b actually is plus infinity? That is the question. And it takes us to calculus 1 limits. Several ways to do it. If you grab the calculator and you plug 1,000,000 in this number, it will tell you what the heck is that. If you plug 1,000,000, 1, 2, 3, 1, 2, 3, you will see what is happening. It's either a huge number or it's a small number. If it's a huge number and positive, that's plus infinity. If it's a huge number and negative, that's minus infinity. If it's a small number like 0.00001, that's 0. It just makes sense. The other way to see it is this way. Limit of 1 over e to the 2b. b still goes to infinity. Now I know this will be like 0, but it's way number 1. Way number 2. Way number 3 is to know the graph. The graph of exponential function looks like this. To 0 at minus infinity. And minus 2 times infinity is minus infinity. That's how we know that the whole thing here goes to 0. So now the second number matters. This integral converges. And it is called convergent integral. And it converges to plus 1/2. Converges to 1/2. Good? Good. So practice that. Practice these guys. This is going to be use substitution, by the way. So it's nice practice to use substitution and then see if one thing is infinity, everything is infinity. So I just now need to know it converges to diverges. I don't need you to answer if it blows up to what. Next. And let me check the chat. Should the lower limit of the solved integral be e to the minus 4 over 2?
Sorry, it's kind of hard to do it over text.
I see what you mean.
Yeah, because it's 2 to b.
Duh. That's a good point. I did not even notice that. That's a very good catch. This is not 0. I just got used to it being 0. And plugged 0 instead. Very good catch. Good job. It's 2. So it's e squared. Thank you. Look at that. See? How smart. See? Someone is paying attention. My over 2. Okay, that's good. Yeah. Nice. Thank you. That was good. Let's see. We covered this and that, this and that, this and that. What always left is Taylor series, Maclaurin series. That's kind of same topic. Arc lengths, all kind of arc lengths. Repeat that. And polar coordinates. So that's all I can see left. Let's do Taylor series and then be done with that. So polar, we can do a little bit of polar too. Let's do that. So let's do Taylor first. Taylor is hard because you need to remember the formula, you need to know the process. Taylor. But you know, we also have nice videos on these chapters. So that's why I'm kind of hesitant to spend time on this because we already have exam 3 review video and that's very good. Taylor has a formula f of x can be read as the sum enter to the n, and it's from 0 to infinity. That's like a very big deal, one of the biggest achievements of C sub n have a formula, vectorial. That's what you need to know. Series for some kind of function. I think review had a very nice examples. So one was already on the previous exam. It was like x to the 3 or x to the 5. Oh, serious. Maclaurin serious. Sine, your review has sine and cosine, for example. Let's do like something different than that. Log. Let's do some kind of log. Why not? So find Taylor series star. Okay, that's what it means. And 3x minus 7. Let's do parentheses. And it's not. Why not? Then I don't like it being 3x. Too much calculation. Let's do 2x plus 2. Like there's the reason why I'm choosing this. Okay, plus 3. It's not random, I promise. Solution. By definition means you cannot use the previous formulas. And you cannot use them anyways, because a there is 0. If it's 2, everything is messed up. So the formula says that f of x, which is logarithmic function, in this case, will be, oh, it's actually nice to know how to write it down in general, right? So in the sum notation is nice, but some of you don't understand how to use sum notation, then just don't. It's okay if you don't. No derivative, that's zero derivative, at a plus first derivative at a divided by 1 factorial plus second derivative at a divided by 2 factorial plus third derivative at a divided by 3 factorial. And let's keep going. What is missing? So I wrote down the formula for the CNs, right? So I will switch to another color, say purple. And then I will multiply x minus a to the 0 to the 1, x minus a to the 2, x minus a to the 3. There's so many ways to memorize this formula. Either this way, when you first remember coefficients, and then you multiply by corresponding x minus a to the corresponding power. If it was divided by 0 factorial, then to the 0, and so on. Or you remember it right away, 2 over 2 factorial, 3 over 3 factorial, and so on. And like you decide how you like it. Also, you see third derivative, that is cube, that is 3 factorial. So there's like a pattern here. So log function has a series, which is original function, which is log. Let me write down f of a. F at 2 plus f derivative at 2, x minus 2, because a was given as 2. Plus f derivative at 2, x minus 2. You see, second derivative should be squared, should be 2 factorial. Plus third derivative, x minus 2 cube over 3 factorial. 3, 3, 3. It should match. Plus and so on. For example, I told you to find first 4 terms. Let's do it. F is logarithmic function. So either build a table or write down right away. I like the table. F at 2 is ln at 2 times 2 is 4 plus 3 is 7. That's the first guy. F derivative. Well, I guess some people plug it right away. I don't like plugging right away. I can see that's how I would personally make a mistake. So original function is 2x plus 3. Some of you are good at this, they fast. I kind of notice it. I tend to make mistakes, so that's why I stopped being fast at some point. ln 2x plus 3. This kind of like is more careful, which is 7. F at 2 is 7. Then that will be divided by 2 factorial. C sub 0 becomes ln of 7 divided by 0 factorial, so corresponding factorial. And then that will be multiplied by x minus 2 to the 0. And this together is the first term. The first term. Multiply. Multiply. Now you take first derivative. 1 over 2x plus 3. Derivative of log is 1 over input. Am I missing anything? You tell me while I'm writing down the second part. F prime at 2 will be 7 at the bottom. Let me check if people know. Did I miss anything or not? Shouldn't be 4. 2 times 2 is 4 plus 4 plus 3 is 7. Oh, that's the previous example. So there's a mistake here. Chain rule says times 2. When you differentiate log, it will be 1 over u times derivative of u times derivative of the function inside. That's times 2. Chain rule. Chain. You maybe did not see, but I raised my finger up. Chain rule. So 2 over 7. C sub 1 will be 2 over 7 multiplied by 1 over 1 factorial. So divided by 1 factorial, basically. It times x minus 2 to the 1. This is a second term. You see, that's how you find terms, basically. Multiply. Third term, second derivative is derivative of that is now going to be a power rule. 2 multiplied by 2x plus 3 to the minus 1. Minus 1. Minus 1 goes down, so it's minus 2. 2x plus 3 to the minus 2. And chain rule says don't forget to multiply by 2 one more time because 2 is inside over here. Chain rule one more time. Chain. Plug in 2, second derivative, f2 becomes, I don't know if you want me to simplify or not, doesn't matter to be honest. Minus 2 and minus 2 and 2 is minus 4. 2 times 2 is always 7 basically inside. So it's 7 to the minus 2. You can keep it as it is, nobody cares. C sub 2 is minus 4. 7 to the minus 2, which can go to the denominator. I will put it actually in denominator because then the pattern is very nice. It's 7 squared. So it was over 7, now it's over 7 squared times 1 over 2 factorial x minus 2 squared and so on. And you see the pattern here. Okay, so let's see, I asked you to find 3 terms, not 4, just because I'm getting tired of this 8 p.m. situation. The answer will be ln 2x plus 3 has a Taylor series at the center 2, and it is ln of 7 times x minus 2 to the 0 over 0 factorial plus 2 over 7 times x to the minus 2 over 1 factorial plus, well, actually minus 4 over 7 squared times 1 over 2 factorial or divided by 2 factorial x minus 2 squared plus, and keep going. Can you do that on the exam? Basically, that's what you did on the previous exam, to be honest. If this is free response question, it's going to be exactly the same. If not, then it's a multiple choice question. Can you do that? That's a very good example. So practice more examples in the review. They're like sine is over there. Before we did x to the minus 5. Remember? And so on. So nice. Looks very nice. What if I give you derivatives? Do you remember that? There's like a review question on that. What if, here we are, example 2. What if I told you that, trying to see, my eyes are like, nope. The original function at 0 is 2. The first derivative at 0 is minus 2. The second derivative at 0 is 2. The third derivative at 0 is 0. And the fourth derivative at 0 is 7. Can you build a Maclaurin series? Build the it's a Maclaurin series. So MCL is Maclaurin. Sometimes you say it right like this. Sometimes it's MACL. Maclaurin series by definition means A is 0. So that's why they never mentioned this. Maclaurin series is Taylor series at the center 0. Maclaurin series is the same formula, just A is 0. So it will be well, let me write down, I guess. F of x becomes original function at 0 divided by 0 factorial x to the 0 plus the first derivative at 0 divided by 1 factorial times x to the 1 plus the second derivative at 0 divided by 2 factorial x, not minus, so it's minus 0 every time, x squared. Nobody put parentheses actually. That's not necessary. Plus a third derivative at 0 divided by 3 factorial x cubed plus a fourth derivative at 0 divided by 4 factorial x to the 4. Do you see that the shift is still there? It's x minus 0 to the power, but since x minus 0 is x, nobody writes it down. This is the definition of the Maclaurin series, plus it and keep going, plus it's infinite. Maclaurin series. Maclaurin series. Yeah, so interesting that we say in my language we say Taylor in Maclaurin, and in English they say Taylor in Maclaurin. So since I already gave you all those parts, there's nothing to calculate. This is 2. This is minus 2. This only derivative, though, be careful. No factorials. This is 2. Third derivative is 0. Fourth derivative is 7. So just plug it in. It will be f of x becomes 2 minus 2x plus 2x squared plus 0. How about fast? Very fast. If you know the formula, very fast. What do you think about this? Ask me, comment. How many people still here? Not too bad. Could be worse. So what do you think about that? So that's actually nice. If they give you this equations, that's nice. Okay, the last thing I will show you, numerical you'll do by yourself. The last thing I will show you will be some polar stuff. And then we're good to go. Yeah. Polar and arc. Polar and parametric. Let me show you both. Wouldn't be 7 over 4 factorial? Yeah, you're right. See, I completely lost factorials. Good job. Maybe I did it on purpose. Maybe not. 2 factorial, 3 factorial, 4 factorial. See, good job. Someone did pay attention. Nice. Parametrics and polar. Parametric and polar. Polar is just one of the cases of parametric with 2 parameters. So let's see what's going on here. Parametric was written that x can depend on some kind of function of t, and y can depend on some function of t. I guess let's do parametric first, not to confuse. T has its own domain. So what we need to review is just formulas. There are only three new formulas show up. Let's calculate how many formulas we have. Derivative was different. dy over dx now have to be separately differentiated with respect to t. So some people write down it's f prime ft and g. No, actually the other way around. Denominator always, the second always goes first. G prime at t and f prime at t. I don't like teaching it because like this, it's too many variables, too many names. So I like to show it specific with dy with respect to t and dx with respect to t, like so. So if I ask you to find slope, you do that. Differentiate, plug in a number t. That was the first form. Then the arc length was different. It was integral from a to b as square root, but not 1 plus derivative squared. Now we have 2 functions. So you have derivative squared plus derivative squared. Dx over dt squared plus dy over dt squared. And order doesn't matter here with respect to t. Did we do area? I don't think so. Oh yeah, we did not do area. So there are only 2 formulas then. That's it. That's what you need to know. And you need to know how to get rid of that and stuff like that. So let me go to polar and then check examples. Polar has more formulas. Polar says x is r cosine theta. Remember that, the order matrix. From here, x squared plus y squared equals r squared. It's literally from that first formula. From the triangle, Actually, if you divide this guy, you'll get, if you divide y over x, it becomes tangent, and that's where the theta comes in. The theta is tangent of theta y over x. It also comes not just from the triangle, but also from this first equation. So remember that. And formulas show up. So arc length now is from alpha to beta as square root original function square. And the area has 1/2 in front of it because of the sector formula from alpha to beta. So because it's d theta, theta is from alpha to beta, r squared d theta. See, I remember. Even like it's 8 p.m., I remember. That's good. Nice. And that's what you need to know for the formula cases. And the examples. Examples are find a derivative. You know how to do that. Jump from and to. And that's what we did actually. Last couple of classes, we did that. And when we were learning all of these examples. R equals 5/2 theta. Can you convert this into Cartesian? So from polar to Cartesian. It's not trivial how to start, but then it becomes very trivial. You multiply everything by the denominator to get rid of the denominator. It will be r times 2 cosine theta plus 4 sine theta equals to 5. Did you see what I did? I multiplied by the denominator. Everything. Left hand side and right hand side. Now left hand side becomes 2r cosine theta plus 4r sine theta equals to 5. This goal gives us the needed formula. R cosine is x, r sine equals to 5. Can you do that? See, like this homework, actually, the homework 9.3 help you to practice these little things. They're easy, but you need to know how to start. They're not easy to start. Like, how did I know to do it at the beginning? Only because I did homework. So you have to do it too. And there's one more tricky one. That's number one. The second tricky one is r equals 8 cosine theta. To do that one, same thing. You multiply by r. It's a different trick. So you need to know the trick. To know the trick, you need to do homework. And if there's no way on a stressful situation, you will guess to do it somehow by yourself. Maybe you can. I don't know. Maybe you're very smart. So I should not assume you cannot. R times r is r squared or r sine theta. Basically, the idea is I want to have r cosine theta and r sine theta, but I don't have it. So let's multiply by r. Then r cosine is x, r sine is y, r squared is x squared plus y squared. That's one of the formulas I just reviewed. So the answer becomes x squared plus y squared equals 8x plus, I said plus, yeah, my tablet is like, no, too much, right? 4y, and this is the answer. In the homework, they ask you to keep doing this problem and figure out the radius and full square. I don't do it on the test. That's just stupid. Like, under the stressful situation, they expect students to create a full square without making a single mistake. That's stupid. So this is a good answer. I feel like it's a good answer. It's some kind of circle with some kind of radius. Well, actually, radius we know. With some kind of, no, we don't know radius. You have to create a full square to know the radius. And some kind of shifted center. So I like it this way. This way is already good enough. And the previous example, also good enough. Like that thing, yeah. I don't need anything extra. This is good. This is maximum. This is full credit. No full square. You don't have to practice that. Now, if I ask you to find the, like so, example, I will check the chat in a second. Let's jump back. We did not practice jumping back from Cartesian to polar. If I ask you to jump back, that means from x squared plus y squared equals 6. Jump to polar. Well, duh, we don't really know many things. You just plug it what you know. And you know that x is r cosine theta. Well, then square it. Y is r sine theta. Well, then square it. X is r cosine theta. And then, what I was trying to say, I guess simplified. Let me see what I want from here. Well, yeah, just simplify. So r square cosine theta plus r square sine square theta equals 6r cosine theta. How to simplify that? You factor out this beautiful r squared, then you will have r squared cosine square plus sine square, but cosine square plus sine square is 1, maybe 1 I should write down. Sine square x plus cosine square x is 1, regardless of what that x, it just have to be the same. So theta or 2x and 2x or 7.5x and 7.5x, that's a property of trigonometric functions. If the angle is the same, cosine square plus sine square gives you 1. So it's just r squared on the left-hand side equals 6r cosine theta. Now I'm gonna really tempted to divide by r, assuming r is not 0, right? Then it's gonna be r equals 6 cosine theta, and that is the final answer. Can you do that? What do you think about that?
Quick question.
Mm-hmm.
For the previous one, instead of writing x squared plus y squared equals 8x plus 4y, would we be able to just write it down as r squared equals 8x plus 4y dxn?
No, it has to be one or another one. Good question. When we're jumping between Cartesian, when we're jumping between coordinates, we will have more coordinates in the future, not just Cartesian and polar. We have to get rid of the previous variable completely. So theta and r are now enemies. You have to get the answer without them. If you convert, conversion means you have to get rid of them completely. So you cannot have r equals here. Make sense?
Yep.
Yeah, and then same here. If we're jumping from x and y to polar, x and y are now enemies. So you have to completely have the answer without them. That is, we will have in calculus 3, it will be crazy. We will have more than that. We have r, rho, and phi, and all of this will have equations. And the same thing, we will have to completely get rid of them if we're asked to. So it's kind of jumping from one world to another world, where it's a sphere, for example, instead of the square. And that's the idea here, get rid of one or another one. Yeah, good question. Why we can't just leave? Kyle's like, I never heard about full square until a week ago. Yeah, that's not trivial how to do full square. It's kind of like algebra chapter, but it's annoying chapter. So I also don't like it. You have to like be careful with algebra there and just don't make mistake, blah, blah, blah. Last thing to mention, check this out. Last thing. So for example, then white and blue, it's black. For y equal, no, for r equals. For r equals. See, my handwriting gets uglier when it's late. For r equals, let me check here. 6 sine theta. Yeah. A. That would be my quiz 11. If we would ever have time for quiz 11, I would do this in quiz 11. Find arc lengths or lengths of the curve. Arc lengths on theta from 0 something pi over 2. Who cares? Something random. Whatever. I give it to you. Don't be worried. Don't worry about that. Then L equals from 0 to pi over 2, and this is when you stuck. Hopefully you remember the formulas and the difference between them. But if not, try your hard not to mess up. Arc lengths always have a huge square root. That's supposed to trigger the memory of the formula. D theta at the end. And then it's original squared plus derivative squared. Original squared is 6 sine theta squared, so it's r squared, plus derivative squared. Derivative of sine is cosine, so it's going to be 6 cosine theta squared. That's good enough. So do you get that? That like if I ask you to calculate that, you can practice it at home. We did it in class, so I don't want to spend time on this. But the whole point is to know the formula. Do you know the formula? Yeah, that is important here. B, find the area. B, find area. I will not ask you to find limits of integration. I feel like people keep getting stuck on it. So on theta from 0 to pi over 2. I can see people stuck with area all the time, so I just decided not to ask for it. I just need to know if you have a formula in your mind from 0 to pi over 2. And I'm stuck, right? Like which one the formula? I remember that area is not a square root. It's 1/2 instead. Okay, that's really good. Then it is r squared. That's it. Just don't mess up. It's just r squared. So it's 6 sine theta squared d theta. Good. Can you do that? Can you do that, basically? And again, if I ask you to integrate that, it's actually not very hard. It's double angle formula here. You better remember that because we practiced that a lot already. And the last thing we did not do is ratio test, but I feel like let's do one example. Why not? Yeah, let's do one example. Power series. Let me see if there are questions in the chat. Power series. Questions in the chat before I move on, because I'm getting faster since I want to finish. Why it is t r equals 6 cosine theta. Let's see. So derivative. So original squared, that is here, plus derivative squared. And derivative of 6 sine is 6 cosine. Yeah. Good. That's what you need to know. Like nothing too complicated for the test in terms of polar, just this, like the basic formulas. Yet if we move on to power series are these guys, a sub n x minus c to the n, or c sub n and a, whatever has x in it and the shift. Power series then took us to the to Taylor series. So n says from like 0 to infinity. Example from the review. Find convergence diverges, practice that, ratio test, practice that, geometric series, practice that, open interval, practice that. That was the previous exam, if you remember. So I will just do the last one because that's kind of interesting. Oh, practice creating a new series from the old given series. That is also important. So this is the example. Sum of x minus 4 to the n, that is number 66 from the review, and 9 to the n is from 1 to infinity. Find the largest open interval of convergence of the series and the radius of convergence. Example. Find where it converges, the largest open interval. Your favorite ratio test. Ratio test says take the limit of the ratio and see what in the long run it gives you. It gives you some kind of L, and you will have 3 cases. L can be 1, L can be greater than 1, and L can be less than 1. If 1, no. In 4, use another test. If greater than 1, diverges. If less than 1, converges absolutely. That is what's going on here. That is ratio test. And what does this L come from? L is next to long run, gives you L. So everywhere I see n, I plug n plus 1, x minus 4, n plus 1, n plus 1, 9, n plus 1. Well, it did not turn to black. 9 to the n plus 1. That is the first fraction. Multiply by the reciprocal. I like doing that. And 9 to the n, x minus 4 to the n. Don't forget absolute value. I took points off if you didn't, because without absolute value, it actually doesn't make sense. So absolute value important. Now, simplify whatever you can. Limit. Don't forget limit. Without limit, it also doesn't make sense. Actually, all of these things are important. X minus 4 to the n plus 1 over x minus 4 to the n gives you x minus 4. N over n plus 1 is n over n plus 1. Don't touch that. 9 to the n plus 1 is 1 over 9. I'm skipping details because we practice it a lot, so you do it by yourself now. Equals. So what is constant for the limit? N is the only variable. So whatever has N is changing. Thus, everything else I can kick out if I want to. X minus 4 have to be kicked out with absolute value. 1/9 also has absolute value, but because 1/9 is positive, you don't have to have it. Limit absolute value N of N plus 1, also not necessary to have absolute value because in the infinity they're positive. But this is 1. So the answer becomes absolute value X minus 4 divided by 9. That is L. In order to converge, this L has to be less than 1, which means X minus 4 multiplied by 1/9 has to be less than 1 by absolute value. Solve for X, multiply by 9. X minus 4 by absolute value have to be less than 9. This form gives you the answer of the radius and the center. Center is 4, A is 4, radius is 9 right away. From here, you can see the radius right away. Now keep solving. X minus 4 is from -9 to 9. X is 9 plus 4, that's the easy one, 13, minus 9 plus 4, minus 13, right? No, but somehow many people gave me that answer. I don't know why. -9 plus 4 is, that took me a while, 5, minus 5. Minus 5, minus 9 plus 4 is -5. So that is the answer. Interval from -5 to 13. And you can always check, radius better be 9 and the center better be 4. So what is the center from -1 to 13? Well, if you add together, so like what is the middle, right? It better be 4 or else something is wrong. That's how you should check yourself at some point. It's good to know. So 13 minus 5 is 8. 8/2 is 4. So center is 4. And then step size from 4 to 13 is 9. -5 and 4 is also 9. And that's how you know that you did not mess up. You can always check yourself. Can you do that? That is on the largest open interval. And practice building new series out of old series. That's the one we reviewed many times, so just watch my previous videos. And also, I left you to practice numerical integration by yourself. Let's actually check what we did not cover. So we know what's going on. We covered in class use substitution. We covered integration by parts. We covered strict integrals. If you think it's not enough, check my previous videos. The tail and how you choose u with the u, and also when to plug sine or tangent, blah, blah, blah. We covered integration by fractions, so partial fraction decomposition, PFD. Integration with tables, we covered. Numerical approximation, just check 2 formulas, trapezoidal rule and Simpson's rule, 28, 29 is good enough. Leave those 2 examples again. Improper integral we covered, but there are more cases, so I would practice improper integrals. That checks your knowledge on functions, limits, and integration skills. Area between curves we covered today as part of the area volume topic. Volumes, disks and washers we covered. Volume, shell minute we covered. Arc lengths, 1 plus derivative squared in a square root formula we covered. Work, tank we covered. Sequences, skip sequences, I did not put them on a test, they're too simple. But series, I did put series. So you see this number 60, 61, and so on. So limit ratio test, it's basically ratio test. Ratio test right now, I did number 66 right now. That's what we covered. I did not cover this one, representative functions as known as power series using known power series. So practice that. We did it many times in class. Taylor Maclaurin series, I covered knowing derivatives and building from scratch. Practice that, both. Parametric equations, find the derivative. I covered that. Eliminate the parameter. Calculus with parametric equations. Find the horizontal tangent line, vertical tangent line. I covered it in my videos, so it's also in your homework. You can just review that. It will take time, so I want you to review it by yourself. Dy over dx into slope. I covered that. See, number 83. Find the equation of a tangent line. We did this in class. I clearly remember that's actually example, product rule, and it's in your home. It's product rule there. And I just covered it right down as a formula. Polar equations, I did right now in front of you, 85, 86, and 87. I did all three right now in front of you. Arc lengths, 9.4 has only two formulas, arc lengths and area. Square root of, I already forgot, r squared plus r derivative squared, that's arc, and area, 1/2 integral r squared, that's area. Good, that's all, check it out, very good. That took 2.5 hours, as always. That's why these reviews are always exhausting for me. But if it's helpful, I'm glad. So let me know. What do you think about this? All of that stuff. Any questions? Questions, ideas, suggestions? This makes me feel more confident. Usually that's what people say. I like giving review because I feel students feel confident. Because seeing a big picture helps, like not just homework number 7 and so on. And seeing like, what did we learn? And we learned a lot. Big high respect to all of you because we learn all of this. Look at this. We're starting with so many things. Use up, integration by parts, all of this. That's a lot of chapters to cover, especially the end was challenging. So you see I color coded by exams. Green color was first exam, blue color second, and then third in yellow. So hopefully it helps you. You can rewatch. I can post this note I just made for you and just keep rewatching, doing it by yourself. The most important is to practice without the notes. If you keep practicing all of this with formulas in front of you, you're kind of setting yourself up on the exam to freak out. You will have no formulas and your brain will tell you, you cannot do this. You're not good enough. It's like imposter syndrome is a very strong feeling. So you have to practice at home without formulas to make sure you know it. And you tell your brain, hey, I know it. Like, shut up. I'm going to do that. And then your brain will be okay with that. Very good job, people. Thank you. And keep practicing. Good luck. Don't forget one of the assignments is due tonight, but it's for extra credit. So you don't have to